we have, in 1998, the population of West Goma is modeled in this particular model, right? There, oops, I kind of drew over it. And then this particular model here is the East Goma in millions. And so what we know is that when x equals 0, it is 1998. And so assuming that these trends continue, estimate which year the population of West Goma and East Goma are equal to one another. So now one way that we could do that is by graphing both equations and finding when they intersect, and that'll give you when they have the exact same population. So let's do that. So if I enter in the equation 16.1 times I'm not having any luck today with my technology. Times, okay, we got it. Times z raised to the 0.001 times x. That's the first equation. And then the second equation is 14.4 times e raised to the 0.0108 times x. Now the windows, I happen to know what the windows will be because I did this problem last class. But let me tell you my thought process. If I look, we're going from 1998 and the largest year is 2009. So what's the difference between those years? Yeah, it's not more than 30, right? It's like 20. So what I'm going to do, x equals 0 represents 1998. So I'm going to start at 0 and go to like 25. So it'll fit it. Now my y values represent the population in millions. Well, what's the lowest my population will be? Well, it'd probably be the 14.4, right? Because if I let e be raised to this number times x, if x equals 0, it's like e to the 0. E to the 0 equals 1. 1 times 14.4 is 14.4. So I'm going to let my y value, my y minimum value, well, we're going to leave that at like 14. And then I don't know how big it'll be, but I'm guessing probably 30, right? Because those are very small numbers in the exponentials. They're less than 1. So I'm going to say 30, and then I'm going to graph it and see what the graph looks like. So there's one graph. And then here comes the other one. And so in order to figure out, remember, one graph represents the population growth of East Goma, and the other graph represents the population growth of West Goma. And we just want to see when they're the same, which is the intersection. So if I hit second trace calc, and I choose option number 5, which is intersection, and I get my cursor pretty darn close to where they both cross, hit enter, 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 and it says that it crosses at about 11.4. So when x is equal to 11.4 roughly, then the y values for both functions are about 16.3 million. So wait a minute, I've got 11, right? Is that the answer? 11? No. Why? No, that's not the year. It's 11 years. It'll take 11 years from when? 1998. So what do I need to do?
Add 11 years.
Yeah, so if I say 1998 plus 11.38 or whatever, guess what we get? 2009. Guess what the answer is?
2009.
You can't see it because I've got my screen, but that's the right answer. Does that make sense to you guys? All right, what's the next one on the list, number 10? All right, so now number 10, it says determine if this is exponential growth or exponential decay and find the constant percentage rate of growth or decay. Well, really, we have 7.5, 1 plus 0.08 raised to the x.
8%.
What's the rate? What's the percentage rate? Isn't 1.08, isn't that the same as 1 plus 0.08?
Yes.
What's this as a percentage?
8%.
8%. Now, is that a growth or decay? It's a growth. You know why?
Just adding.
Because you're adding. Whenever we're adding, we're growing. If this were a minus sign, it would be a decay. So remember that decay has a minus sign in between there. So what are we saying? 8% growth? There it is. Does that make sense to you guys? Okay. I want to go fast so we can cover a lot of them because really you should kind of know what these are. But just in case you don't remember. So now they gave us a bunch of information and they want to know which one of these will have those numbers. Well, I think this is pretty easy when you consider that when we say y is equal to a times b raised to the x, what happens when x equals 0? B is 1, so y equals a. Does that make sense? So it's not this one, and it's not this one. Now you could pick any point on the line over here and plug it in. So we know what a is, right? What's a? 20.25 times b to the x, right? Now we just got to solve for b. Well, we can pick out any one of these values and then work backwards, right? Or what's another way? I could just plug it in my graphing calculator and see which one works. So what I'm going to do is I'm going to plug them both into my graphing calculator. I'm going to clear this one out, and I'm going to do 20.25 times 1.5 raised to the x. Then the next one is going to be 20.25 times 1.33 raised to the x. And I'm just going to look at the table. All right. Oh, I'm counting by funny numbers, so that's a different problem I did for another class. So I'm going to start by 0 and count by ones. And now if I look at the table, which one matches up? When x equals 1, y equals 30. When x equals 2, y equals 45.563, which the calculator rounds. So it's function number 1, which is 1.5. Yep. So it's this one here. Does that make sense? You guys see how I did that? Okay. Good, good, good. What's the next one? Problem number 13. Okay, this one is not that hard. Remember, this one is going to be the function f of x is equal to c over 1 plus a times the quantity b raised to the x.
Could we bring a flashcard for
You know what? Just remind me. We'll write it on the whiteboard.
Okay.
Okay. We'll write that formula on the whiteboard. This c is easy because c is always the limit to growth, right? That's a L. C is always going to be our limit to growth. So in this case, it would be 48. Now, they give us the initial value, which is 16. Now, the initial value occurs, basically what they're saying, when x equals 0, y equals 16. Or instead of y, if you use function notation, you could think of it like this. This is like, it's still x, but this is like f of x. So then I would put 16 here, and then I'd have 1 plus a times b to the 0. What's b to the 0? 1. So what I'm left with is 16 is equal to 48, right? All over 1 plus a. Well, 48 divided by 3 is 16, so what's a have to be? If you're not sure how to do that, another way you could do is when you cross multiply, you'll get this 1 plus a is equal to 48 over 16, which is equal to 3. So what's a got to be? Dose, right? So a is equal to 2. So we've got c is equal to 48, a is equal to 2. The only thing I have to do now is find b. I'm going to erase this real quick so I can have some room. Alright, now to find b, I'm going to plug everything in, and we're going to use this last little tidbit of information here. So I've got f of x is equal to 48 all over 1 plus 2 times b to the x. And so my y value is 32, and b is equal to 1. Or I'm sorry, b raised to the first power is equal to b is what I meant to say. And where does this 1 and this 32 come from? This point right here, right? Does that make sense? I'm going kind of fast. I just want to make sure you guys are keeping up with me. Now when we cross multiply this, over here we're going to get 1 plus 2b, because b to the first power is b, is equal to 38 over 32, which reduces down to 3 over 2 if you divide the top and bottom by 16. Does that make sense? Am I going too fast? If I go too fast, say slow down.
That's not cross multiply though, because when you multiply 32 by the 1.
You get 32 times this quantity, and then you divide by 32.
Alright, I missed that
Why don't you trust me?
part.
It really hurts my
You gotta write
feelings.
it down.
Do you trust me?
That's because he's trying to go fast.
Trust me.
Skipping some steps.
Take this pebble from my hand, grasshopper.
You're gonna close it.
Luke, he is your father.
All right, Luke, I am your father. All right. So then, what does that mean? Well, 1 plus 2 times b. So if I subtract 1 from both sides, I got to make some room. I thought I was going to be able to do it. So if I take that over here, then I've got 1 plus 2b is equal to 3 over 2. If I subtract 1 here and I subtract 1 here, I get 2b is equal to 1/2. And you say, Mr. Adams, how do you know that 3/2 minus 1 is 1/2? Well, 1 is the same as 2 over 2 is one way to look at it. Or 3 over 2 is 1.5 or 1.5. When you have 1.5 and you take 1 whole away, what are you left with? 1/2. For example, if there were 3.5 cell phones out and one of my students was on their cell phone and I took 1 away, I would only have 1/2 of a cell phone left.
How do you have half the cell phone?
Yeah.
That's complicated. That's kind of
Just flip phone.
So now,
Mine counts as half.
how do I get rid of this 2? We're not done.
Divide.
Or I can multiply by 1/2. Whatever I do on one side, I do to the other. What's 1/2 of 2?
1.
1 times b is? We're done, right?
No, you have 38.
Now you gotta pick, which one of these is it?
Hey.
A. Yay! You guys are smart. You guys ready?
Where's you at?
Sometimes Y.
Do I mean that?
Oh.
Yeah, you guys paid attention. When I ask you a question, you know the answer. Alright, so, you know what?
Where you at?
We're at 6.
Test on Friday.
Yay! What?
Three.
Yeah, I want to go over all these with you guys.
Oh,